Morning, everybody. Today we will talk about electromagnetic waves and especially the electromagnetic spectrum, and we will talk a little bit about light dispersion. Okay, as you can see the picture here below, this is the electromagnetic spectrum of electromagnetic waves, and you see this is a huge region with different types of electromagnetic waves, and we will discuss all of them. Okay. The electromagnetic spectrum. First of all, we will understand that light is part of a continuous electromagnetic spectrum which includes radio waves, microwaves, infrared waves, visible light, ultraviolet rays, X-rays, gamma rays, and all these waves, they travel at the same speed in free space, and the speed of these electromagnetic waves is always 3 times 10 to the power of 8 meters per second, or 300,000 kilometers per second. We will also discuss some uses of the electromagnetic radiations, or we may say electromagnetic waves. We discussed radio waves, which are used for broadcasting and communication, microwaves for cooking and satellite transmission, infrared heaters and night vision, visible light, optical fibers and photography, ultraviolet fluorescent lamps, X-rays, observing the internal structure of objects and material, and some medical applications, and the gamma rays, sterilizing food and medical equipment. Okay. And as always, as I say, if you want to make notes, just stop the video and take your time, make some notes, okay? First, we start with dispersion. Ever seen this picture? It's actually a very famous drawing, and it's one of the most famous records in the world, and it is a record from Pink Floyd called Dark Side of the Moon. If you have the time, I really would recommend to listen to it. It is still incredible. Okay, dispersion. What will happen if we shine white light on a prism? Yeah, so what the white light is going to split the light into a spectrum, and we call this dispersion. The different colors, red, orange, yellow, green, blue, indigo and violet, are going to split up because they are going to refract in a different way. Yeah. Now, if we look at this picture, which color has refracted most? That is the violet light, and red is the light that is refracted least. Might have heard about purple fringing in photography, and that has to do actually with the refraction of white light, and wherein especially red and blue light are going to split, and it's like they make like a border, and together they make the color purple, and that's why we call it purple friction. If you're not sure, there are different ways to remember the different colors, but I think most of you know it. But you could use Richard of York gave battle in vain. Yeah? Okay. Now, we see here that white light splits up into different colors. Now, let's see if we actually combine the colors, if we would get white light back. And we're going to do this by looking at Newton's disk. And you might have done this before in your year 8 science, if I'm not correct, or year 7 science. And as you can see, when you combine all the colors together, and if you do it in the right way, you really see that all the combined colors become white. So yes, you can do actually the opposite, which brings us also to the conclusion that white light has actually all the different colors. Okay. You can do this easily at home. There are many videos on the internet that you can find in order to make your own Newton's disk. I used to do this with the year 7 students. Okay. So, in review, on the left side, we see a smaller wavelength. On the right side, a bigger wavelength. Which one do you think will be the left? That is the violet. It has a higher frequency. Remember, the speed of light is always the same. Will it be refracted more or less? It will be refracted more. And the wavelengths are shorter. When we look at the right side, we have red light. It is refracted more, so there's a little mistake here. Refracted less, sorry, by the glass, and the wavelengths are longer. Okay, all right. Let's look at the electromagnetic waves. Remember, all waves do transfer energy, whether it's a water wave, whether it's sound, also light. Yeah, they are energy wave, meaning all electromagnetic waves are energy waves. These are the only waves that can actually travel through a vacuum. Sound cannot travel through a vacuum, remember? And despite the speed of light is 3 times 10 to the power of 8 meters per second. And we are going to group them by their properties and their uses. Yeah? And remember, inside each group there is a range of frequencies. Okay? You need to know more or less the order of the different types of electromagnetic waves according to their frequency or their wavelength. Okay, let's have a look. Here we have the electromagnetic wave spectrum. From the left side, very short wavelength, meaning very high frequency. From the gamma we go to the X-rays, then we get the ultraviolet, then we get the normal visible light, and to the right we move on to the infrared, the microwave and the radio waves. On the left, let's see, where do we have high frequency, short wavelength, high energy, most penetrating? That is on the left side. Yeah, these waves have a very high frequency, a very short wavelength, they have a lot of energy, and they are the most penetrating. Then we have low frequency waves, long wavelength, not so much energy, and least penetrating. These are the low frequency on the right side, like microwaves and radio waves, low frequency, long wavelength, low energy, and least penetrating. So when we look here, and actually we could use the wave function, yeah, the velocity equals to the wavelength times the frequency. Now remember that the speed of the electromagnetic waves is always 3 times 10 to the power of 8. When we move to the left, we have an increasing energy. When we move to the right, we have a decreasing energy, and we have an increasing wavelength. And let's look a little bit at the numbers. Now, as you can see, the visible light is only a small range, very small range compared with the other electromagnetic waves, yeah? And when we look at the light, the highest frequency is violet on the left side, and when we move slowly to the right from blue, violet, indigo, blue, green, yellow, orange, and red, we have a lower frequency but an increasing of wavelength. On the left side, from visible light, is ultraviolet light, which has a bigger range, more energy, can damage your skin, remember? X-rays, and then gamma rays. When we move from the right side of light, we have infrared light, big range, microwaves, and radio waves. Okay, let's have just a small starter about the electromagnetic spectrum. Yeah, to explain a little bit about the dangers and the uses of the electromagnetic spectrum. Let's start. Light of a type of radiation is part of the electromagnetic spectrum. True or false? True. The electromagnetic spectrum is made up of different types of radiation. True. The different types of radiation have different properties and behavior. True. All electromagnetic waves can travel through space. True. All electromagnetic waves travel at the same speed, 3 times 10 to the power of 8 meters per second, or 300 million meters per second. True. Okay, and now we will explain a little bit about the uses and the dangers of the electromagnetic spectrum. You see already in the picture, visible. I see a thermometer with infrared. I see microwave heating up food. I see radio waves. On the left side we see ultraviolet coming from the sun, X-ray, bones of your hands, and gamma rays, dangerous. Okay. I would recommend you especially to copy this table in order for you to give a clear view of the different uses of the different types of electromagnetic waves and the dangers of electromagnetic waves. Okay? So again, pause the video, copy the table, and then we're going through all the different types of electromagnetic waves. I would recommend you that you use a complete page to fill in, okay? We start on the left side of the electromagnetic waves, the gamma rays. Gamma rays can be used to kill microbes. They also can be used to sterilize medical equipment. They also can be used to treat brain tumors. We have in the middle a tumor, around it a healthy brain tumor. We have the skull and the view through the head, because gamma rays can penetrate through everything, but there's a way to see the difference of the tissues inside the brain, and they can make a three-dimensional picture of the tumor and see exactly how big the tumor is. In conclusion, uses of gamma rays are used for sterilizing surgical equipment and food, and for the use of killing cancers. Now, as you remember, when we move to the left side of the electromagnetic spectrum, the electromagnetic waves have more energy and they are more penetrating, which means they can kill cells. Even lower doses can cause cancer like brain, liver, bone, and leukemia, and it also could cause sterility. So fill in your boxes. When we move slowly to the right, we have the X-rays. Familiar with this picture? Mr. Simpson and his big brain inside. Okay. Now, in order to check if there are cracks on the wings in a jumbo jet or in an airplane, we use X-ray tubes. Micro cracks could cause a big danger if they are appearing in the wings of an airplane. Yeah, so they need to be checked very careful over a period of time. Yeah, so they are regularly checked and to see if there are microcracks, because if there are microcracks, they can actually become bigger and bigger and the wings could fall or break. Yeah, now you cannot see these cracks, so you need a special method to find these microcracks, and we use X-ray tubes for this. A more common use, and you probably have done maybe some X-ray imaging, maybe when you had a broken teeth or problems with your teeth, or when you had a broken arm, or they suspected that you broke something, a bone. Yeah, here's the X-ray tube, and it's used to detect broken bones. And you see, there's some broken bone there, I believe, here on the right. Yeah. It also can be used to check if there are organs that are damaged in your body. What they do, they put in a special fluid in order to detect X-rays and see if the different organs of your body is actually, if they are vital, okay, if they are healthy. Now, in evaluation about the X-rays, the uses are another one that you might have missed when you go to the airport is shadow pictures of luggage and inside the human body. Now, X-rays, they still have a lot of energy, and high doses can kill cells, and even they can cause cancer and may cause sterility. So again, fill in your box and put all the uses and dangers of electromagnetic radiation. Ever been to a discotheque? Sometimes they use ultraviolet light, or maybe some special shows you might have seen on television. We use them in different ways. Ultraviolet light comes from the sun. On the right side you will see a picture of the sun, wherein we only look at the ultraviolet range of the light that is coming from the sun. We see on the left side a bill of 50 euros. There are some things that you normally don't see, and you might have been to a shop in order to check whether a bill is real or counterfeit, and they use ultraviolet to double check some different marks they put which are sensitive to ultraviolet light. And the man on the left side, you can use special paint, have a dark background, and then only this ultraviolet paint will show up. You might have heard that ultraviolet may cause skin cancer if you are too long in the sun. Yeah, and I've heard once a story from my father. He used to work for the KLM, and a stewardess, somewhere in the 80s, she was sunbathing in the sun in Singapore, I believe, somewhere on the beach or something, and she fell asleep, and actually, literally, she kind of burned to death. Yeah? Alright, so be careful. Always use sunscreen when you go out and when there is a very strong sun, okay? So be careful. Alright. What are the effects of ultraviolet on cells? Normally we have outer dead skin cells, living skin cells, outer dead cells, living thin cell, and what is going to happen? Yeah, they could actually cause mutations in your cells due to the ultraviolet now, and they could actually cause cancer on your skin. So be careful, okay? Some uses of ultraviolet light are sunbeds. You don't see them here, but when you go to Europe, and in Europe, especially in the northern European countries, there's not a lot of sun during the winter time. And sun actually gives you a vital vitamin. I think it is vitamin D. Okay, I have to double check. People, they are going under the ultraviolet sunlight, or special like spas where you can do this. We have fluorescent lamps to detect counterfeit bills, security markings. Some dangers can be sunburn, skin dance, cancer, and blindness. Now there's another feature, and I saw some videos of David Attenborough. And insects, certain insects, they are actually able to see ultraviolet light. Now, amazing or not, but flowers have been anticipating on that. If we see on the right side, we see a normal flower, which is normally just yellow. Yeah, and the flower wants to be pollinated. Yeah, flowers have like special ultraviolet colors that only insects can see, and they're like signaling, come here, come to this middle, come to this part, come to the pollen, yeah, to pollinate me, yeah. And you see this is the same flower. On the right side you see the normal light, and on the left side you see actually the ultraviolet that an insect can see. It's very interesting. Okay, now we slowly move to the right, so after the ultraviolet we get visible light. The light that we can see. Some things that are used for visible light, obviously looking with our eyes. It's also used in optical fibers. Yeah, what are the applications of internal reflection? Remember, these are the optical fibers, and we use them in communication. Your internet is actually going through a cable somewhere, and we make use of light and fibers because it's more efficient, more accurate, yeah, and it makes use of the internal reflection. And you see, when the light is coming up, due to the different media, the light will reflect, and it's easy to get a signal through without a lot of energy loss. Some uses of the invisible light are photography, endoscopy. You might not have heard about endoscopy. Endoscopy is like a very tiny camera attached to an optical fiber or a special cable that lets light through, and you can bend it, and it's like going into your body to see, for example, when a surgeon is working on an operation, to see exactly what he is doing inside, or even to find some wounds inside your organs. Okay, some dangers: blindness. If you look too long into the sun directly, you can actually get blind. Okay, so now what do you think? What comes after the light? That is the infrared light. Again, a big region of the electromagnetic waves, much bigger than the visible light. You might know already some uses of the infrared light. Infrared light is actually, we can compare it with heat of the electromagnetic waves. Yeah. Now, we have the sun, gives all types of light, even ultraviolet light, even dangerous radiation, but we are protected by our atmosphere. But part of the electromagnetic wave that comes from the sun is the infrared wave, the short wave. Yeah, they're coming from the sun during the day, and during the night the earth loses the longer wave infrared length by radiating them into space, and the earth cools down. Yeah, so during the day, the Earth is absorbing the short wave infrared light rays. During the night, the Earth is losing longer wave length. You might have noticed in buildings, when there was a very sunny day, yeah, and the bricks of a house are heated up, yeah. Now at night, these bricks might still feel warm. That means they are still radiating infrared light. Yeah. Now, discussed already a little bit. If there is too much water vapor and carbon dioxide in the atmosphere, the infrared light might be trapped in the atmosphere and actually will heat up the Earth more than we actually want to, and we call that the greenhouse effect, which is directly connected to global warming. Night vision. Now, all objects that have a temperature, even above, just above absolute zero, they emit infrared light. Obviously, the hotter the object, the more heat radiation it emits, yeah? And there are different parts, for example, of your body that actually are more open to the sky, like your eyes, or certain parts of your skin, or certain parts of your body that are warmer, and they heat up. Now, there are special night vision binoculars or cameras that actually can see how much is your body radiating, and we can make actually an infrared picture. Now, what we see here, we see a house, and we have been talking in thermophysics about insulation, yeah? And we see a house, we see the windows, we see a car which has a motor which probably warm some part of the motor. Now, if we look, when it is more white or lighter, it means it's radiating out more energy, more infrared. Now, obviously, the walls are pretty thick, so they will release less energy, but if we see at the windows, they will release more energy in the form of infrared. So, white means hot, and dark is cold. Some uses of infrared are: we use remote controls for the television. We use radiant heaters and grills. You might have seen them maybe in restaurants. Also, we can use them in optical fiber communication, night vision. We use them in mobile phones, and some dangers are skin burns. Okay. Microwaves. You might have one in your house. A microwave oven. Microwaves are used also for communication between satellites and receivers on Earth. Yeah. Now, microwaves, they can pass through the ionosphere. That means they can make contact with the satellites that are above the ionosphere. Yeah? Because of their shorter wavelength compared with radio waves, they have a higher frequency, they are more penetrating than radio waves. So, microwaves are used for communication, internet, Wi-Fi. Then we have, of course, the microwave. Now, the microwave has a specific frequency that actually can increase the movement between the bonds of the atoms in water. Now, we know most of our food actually contain water, even popcorn. Yeah? Did you ever use popcorn in the microwave oven? Now, what is happening? You put the popcorn in the microwave oven, the water inside the popcorn is going to be heated up. Then the water is going to boil. There's a lot of gas that is being released, and then is going to pop open. Yeah, because of the gas. So, how do we cook food? You have the microwave, you have a glass of water, or could be something different which contains water. And what is happening is that there's a high vibration is exactly the resonance frequency of the different bonds between the oxygen and the hydrogen in the water. It's going to heat up, yeah, and then it will actually heat up the rest of the food, yeah. So they have the exact wavelength that can be absorbed by the water molecules. The water molecules are going to move faster and the water temperature increases. Now, some uses of microwaves are satellite communication, mobile phones, cooking, and radar. Some dangers of radio waves could be some internal heat tissue heating. I remember a case somewhere at the beginning of the 80s, and this was a law case which actually a woman in the United States won. What happened is, well, this woman, she had been washing her cat, and of course she wanted to dry her cat. What she actually did is she put the cat in the microwave. Well, you can imagine what has happened. She tried to complain and she started up a lawsuit, and actually she won it, yeah, because in the instructions of the microwave it was never mentioned that you could put an animal or something like that. And the United States in that way is a little bit strange, but she actually won. Pretty funny. Okay, then we come to our last one, the radio waves. We have short and long radio waves. We have short waves of radio and TVs. They are broadcasted to the line of sight directly, but they cannot travel large distances because of the curvature of the earth. So if you want, for example, to listen to a radio station from Hanoi or even Dalat, it's impossible, and this is because of the curvature of the earth. Yeah, you don't have a direct connection to the station. Also, besides, over a long distance the waves spread out and they lose their energy. So the waves go straight through and we cannot receive any signal in area 2. They cannot travel large distances because of the curvature of the earth, yeah. Short radio waves, they are broadcasted to the line of sight of aerials. They cannot travel large distances because of the curvature. So they are even smaller. We can use actually the ionosphere, but then we have to point our radio wave in a different way, more into the sky, and we can make use of the charged layer of the ionosphere. It's like a difference, and because of that difference, these radio waves are reflected by this charge. Yeah, and remember, all different types of waves can be reflected. And these are special waves, and yes, with a special radio you can receive a signal from the United States, and this goes because of the reflection due to the ionosphere. But you need a very special radio for that. Okay? Now, where are radio waves used for? They are used for communication and astronomy. Some dangers, but pretty low. and you really need a very large dose of radio waves, they could cause cancer. Some questions before you're starting. So we are going to discuss this, copy this, and try to connect the different parts of the electromagnetic spectrum with the uses. Gamma rays, they can sterilize equipment. Radio waves, they can carry TV signals. Ultraviolets, they can cause suntans or sunburn. Visible light allows us to see. Microwaves, we can use them in radar. X-rays, see broken bones. And infrared, use it as a remote control. Which radiations are missing from below? At A we have, of course, the X-rays. At B we have the microwaves. Remember, you need to know the order from the left to the right or vice versa. First we get the gamma rays, X-rays, ultraviolet, light, infrared, and radio waves. And this is it. Don't forget to make notes, and as usual I will send up you this video.